Docker. Build, ship, and run anywhere. Agenda. Container orchestration systems. Docker history. Why Docker? Docker container lifecycle. Getting started. Basic workflow. Build and run. Container orchestration system. Container orchestration is a system that isolates and bundles an application with its dependencies away from the host operating system. If you screw things up or break a build, you can easily roll back to a previous working version. Almost all real projects use some kind of container orchestration. Any company with a clue uses this kind of container orchestration. Companies without a clue are bad places to work. Bare metal and virtual machine systems. A bare metal system hosts application APIs directly on a physical machine and its operating system. A virtual machine hosts application APIs within a boxed operating system, itself running inside a bare metal operating system. Bare metal. Bare metal hosting of Windows. Bare metal hosting of Macintosh. Virtual machine. Virtual machine hosting of Ubuntu runs boxed inside a host OS. Problems faced in bare metal and VM. Single point of failure dependent on access to the physical system. Hard to manage a physical system and its backups. Slower because replicating to different physical environments takes time. Every setup instruction is carried out manually. Difficult to follow 12-factor app principles. Misses out on GitOps principles and deployment automation. Docker container orchestration systems. Application packaging instructions are maintained within a source Git repository. The build Docker image is maintained in a remote Docker registry. An application is packaged along with its dependent libraries and minimal base operating system. Other similar systems. Kubernetes, Pod1, Containerd. Docker advantages. Docker applications run the same everywhere. Speeds up development and testing. Uses fewer resources than virtual machines, saving CPU and memory. Makes deployment simple and consistent across environments. Isolated containers are secure to operate and reduce library package conflicts. Integrates well with CI/CD tools for steadfast delivery. Everything is local, almost. One huge benefit is that almost all executive operations happen locally. Data sync happens in loosely coupled database systems like Microsoft SQL Server and NoSQL MongoDB. Easy to scale horizontally by adding more instances within orchestrations like Kubernetes. Instance failures have minimal impact with no local data to lose. Session state is maintained within external services like Redis Cache. Port mapping and volume mount. Port mapping. A container port is explicitly mapped to a host operating system volume mount. A part of the file system is mapped to a containerized application's log path. Multi-stage Docker file. A multi-stage Docker file uses a first stage to build the artifact and a second minimal stage to serve it. Here the final stage runs only the published app without SDK overhead. History. Released in 2013 by .cloud, later renamed Docker Incorporated. Building on Linux containers, LXC technology. Introduced a simple, portable image format that packaged an app with everything it needed to run. Docker Hub launched soon after, giving the community a public registry for sharing images. Docker Enterprise Edition arrived in 2017, bringing container tooling to large organizations. Today, Docker remains the most widely used container runtime and image format in the industry. Why Docker? Free and open source. with strong community and vendor support. Simple design, one image, one consistent runtime, anywhere. Excellent agility for spinning up and tearing down environments. High speed. Container starts in seconds, not minutes. Handles large projects efficiently with layered, cacheable images. Fully distributed via registries like Docker Hub. Dockerfile. A Dockerfile belongs only in the root of the working directory. Defines every instruction needed to build the image, from base layer to entry point. Read top to bottom by the Docker build engine, one instruction per layer. Never rely on files outside the build context, referenced by relative paths. Docker container lifecycle. Create, start, run, pause, stop, and remove. A container is created from an image, moves to running once started, can be paused and resumed, and it's finally stopped and removed. Getting started with Docker. This leads us to the three main sections of a Docker file. Start from a lightweight base image, work directory, copy and run. Set the working directory, copy application files and install dependencies. Entry point, CMD. Define the main executable with default arguments that can be overridden at runtime. Basic workflow. Write a Docker file, create a image, push it to a remote registry, pull it from a remote registry on the deployment infrastructure and deploy. Docker build and Docker run. Some people call build and run Docker's killer features. Lightweight and nearly instantaneous, layering instructions in images almost as fast as writing them. Encourages a workflow that stages instructions to form a lightweight image. Optimizes image storage remotely with both private and public registries. Supports multiple language builds, .NET, Node.js, Java, and Python. Isolates environments and supports Git-based workflows. Any questions? Thank you.